Up until now, you learned how to perform a calculation. You have learned how to perform a simple calculation starting from the material definition up until the EPW. Then we had EPW calculation where we had a blocking. We arranged them in order to manipulate the calculation. So for example, I want to do phonon with without spin orbit coupling, electronic calculation with spin orbit coupling, and then we had the EPW calculation done. Now in these calculations, you must have seen in my definitions that the EPW uh, calculation had many inputs. For example, this is an optical calculation, so we provided the optical range over which we want to perform calculation. We had some more definitions, and then we had defined the type of calculations. For example, LNDABS basically switches on the optical calculation, and then we had some other definitions. However, EPWpy actually allows you to get rid of defining so many inputs to EPW, and instead you can just simply ignore everything and write a simple magic word, something like an optics calc equal to true. Now this kind of a magic word switches on all the inputs that are required for an optical calculation. So for example, in an optical calculation, you may only be interested in the visible range. So your optical grid is defined within the visible range. It switches on the optical absorption calculation flag and also takes care of many of the inputs that you would not need, would be defining by hand, but are well predefined. So these kind of magic words actually enable calculation of EPW physical property calculation without much input from the user. So you do not really have to tinker around with the inputs, play with them. You just give the magic word and EPWpy will run the calculation and provide you the output of the particular physical property. You can also use something like a transport calc, which is for the transport calculation. And here, if you do, you can see that it has, based on previous calculation, this is the thing about EPWpy, that based on the previous phonon and SCF calculation, there are certain inputs that EPW needs. For example, if the calculation was performed with epsil in phonon, then basically you can account for the long range and it will switch on the L polar tag. So there are many of these inputs that you do not need to specify EPW in the EPW block because those are already noted by EPWpy. And here you can see that the magic word that we had for the transport calculation actually has set input flags for the transport calculation. With this, basically EPWpy gives a very simple method to perform EPW calculation in a single structure and in a single frame. You do not need to provide input files. All the input files are written by EPWpy. You do not need to handle transfer of data because that is also done inside. Many of the inputs, so for example, you missed an input that you did a calculation from, those will already be handled by EPWpy. So there is very less chance of any kind of a mistake. And all these calculations can be performed inside a notebook. You will learn how to launch a notebook on Frontera within the MathCSSI program. At the same time, you can also perform these same calculations on a terminal. So on a terminal, you can basically, so here I give you an example of a calculation with the same setting as the notebook. And here you can basically define these inputs. So here you can define various inputs and you can perform same way, the way you launch a Jupyter notebook, you can do it inside a terminal. You can also, this is something we did not touch, but in an advanced video we will touch this, is you can perform relaxations inside EPWpy as well using a simple structure that is provided here. And with this, you can do any kind of calculation. Okay, so this is now the final part of the video where I'll talk about more magic tricks inside the EPWpy. And this is what we call as the flow calculations. So up until now, you learned calculations which are based on pipelines, which are based on blocks, but now, and which have magic numbers to make your life easy. But you can make the calculations even more easier and minimalistic with what we call as the flow calculations. In a flow calculation, what we have is that we define the material, and instead of the 3-point that we had architecture that we had in the beginning, where you have a method, then you prepare and then you run, instead you just define the method one by one in a system like this. So for example, SCF, phone on, and SCF, and then you just have one single block of EPW. And eventually in your run, you basically type something like transport, and this is going to perform a transport calculation, but without any kind of explicit definition or without any kind of execution of each block. Rather, all blocks will be executed at once. So if I pictorially show what a flow calculation is, a flow calculation looks something like this, where starting from the material definition till the end, this entire thing is actually encapsulated inside a single execution. And this is what is performed using this silicon.run. In our case, silicon is our material. And here, by defining type run equal to transport, we have basically performed a transport calculation without much hassle. And this is all done inside just a very minimalistic input structure and in a single cell. These kind of calculations will be very important if you want to perform high throughput calculations with EPW. And EPWpy basically enables these calculations. So here you can see we have executed this, and when we run this, we have SCF and SCF and the phone-on calculations that go through, and then eventually it comes to a transport calculation. So here you can see it just says inside the transport flow. It of course tells you that you need to check what is the input that is being written by the EPWpy, and inside this flow calculation, it basically performs the coarse grid unfolding and the transport calculation all by itself. Here it also writes the information or the input tags that it has switched on. Similarly, just like you have a transport flow calculation, you can have an optics flow calculation, a superconductivity flow calculation, or a polar-on flow calculation. In this video, you learned how to really do the structure. Starting from the material, you define the structure, various ways of defining structure, block-based architecture of EPWpy, how you perform an EPW calculation, how you execute these different blocks, how EPWpy has various magic numbers, magic words, which can be used to ease the calculations. And eventually we did the flow calculations, where we have a very minimalistic structure which performs a type of a physical property calculation, for example, transport. It can be optics, superconductivity, those kind of stuff. And this concludes this video. In a later video, you will learn about various visualizations that EPWpy has. For example, band structure, how you visualize the data, mobility, optics, or even polar-ons. And with that, I basically conclude this video. Thank you.